Good morning, classroom. So for today's lesson, can anyone tell me anything about the law of universal gravitation?
It's a law that states that every particle attracts in the universe with a force that is proportional and, but I memorized it from the dictionary. I did. I forgot.
No, wait. Instead of memorizing, let's try to understand this simply. When you drop an apple to the ground, it falls as a result of gravity. So we know that every object attracts every other object due to both objects having mass. It can even be you and your computer. Just remember, the larger the mass, the greater the force of attraction. So let's see an example and take a quick journey into space. Sometimes you can't feel the force because it's very small compared to our huge planet, Earth. This force of attraction is larger than any other object around you. Here we have Earth. Planets orbit around the Sun and have a radius for its orbit called the orbital radius. The time it takes for one revolution is called the orbital period. Now when we divide them, we'll almost get 0.040. And if you calculate it with other planets, you'll still get the same thing. So long ago, scientists were pretty surprised about this, and they actually didn't know what pulled the planets to move. Until finally, in 1687, Isaac Newton published a theory of gravity. Newton said that the total force of an object is equal to the product of its mass and acceleration. The value for the acceleration of gravity is most accurately known as 9.8 meters per second squared. But the force of gravity is not the same for all objects. In fact, it depends on its mass. The gravitational force pulling an object is proportional to the object's mass, which means here, the gravity force pulling on both objects, so both the apple and Earth, is proportional to its mass. It says that the gravity force provides the net centripetal force and pulls the moon around. We can take the speed and put distance over time, which will be the circumference. Now that's simplified and multiplied both sides by t squared over r. And we almost end up with Kepler's third law, except we need the r to be cubed. So since the force of gravity has to be a constant divided by r squared, Newton said that the force of gravity is proportional to the inverse of r squared. When we take them all together, we can express it like this. So this can be written as a formula where g is the gravitational constant. This is the currently accepted value of g. And now we have Newton's law of universal gravitation.
Thank you very much. I really hope this was helpful.